Determine the sum of 10 terms of this series, and this series is not an arithmetic series, it is a geometric series. But we will treat it exactly the same, except that of course we are now working with a constant ratio rather than a constant difference. There is a formula for calculating a geometric series which we are going to look at now. This formula can be written in two ways. You can see that they differ in the numerator and the denominator merely by a sign. We use this formula when r is larger than 1, and this formula works better when r is smaller than 1. But if you forget when to use which one of these, you will still get the correct answer regardless of which formula you use. If we now go back to the question, we want to add together 10 terms, so we know that n is equal to 10. The value of our first term, a, is equal to 2, and the constant ratio we can calculate. 6 divided by 2 gives us 3, and test 18 divided by 6 also gives us 3. So now we can write down S of 10. We are going to work with the first alternative of the formula. The value of a is 2, r is 3, and we raise it to the power of 10. Subtract 1 and divide it by r minus 1, which is 3 minus 1, 2. The two 2's can cancel out, and I get 3 to the power of 10 minus 1. This is a very large number, and therefore we leave it in this format. Determine the following. Here we once again have a sigma notation. When we have a sigma notation, we know we must add. So let's write down the first term. The term is going to be a half times 5 to the power of 1 minus 1, which is 0. Term 2 will be a half times 5 to the power of 2 minus 1, which is 1. Term 3 will be a half times 5 to the power of 2. So here we have our first three terms. You can see we are multiplying each time by 5. So term 1 will be a half, because 5 to the 0 is 1. R will be the constant ratio, and that is 5. The question asks us to add terms together and find the answer. How many terms? If we go from 1 to 6, then there are 6 terms to add together. We must calculate S6, the sum of 6 terms. When we substitute the values into our equation, then we get 1953 as the sum of 6 terms of this geometric series. From this sigma notation, we could write down the first 3 terms in order to determine whether this was a geometric or an arithmetic series. From these terms, we could determine the constant ratio and the first term, but if you look at this formula, you can see that it is actually in the form a times r to the power of n minus 1, which is the general formula for a geometric term. And from this term, we would be able to deduce the value for a as well as the constant ratio without having to write it out. Determine the value of the following series. The first term is given as 18, so a is 18. Then we see that we have a constant ratio, so it is a geometric series. What is the value of r? 6 divided by 18 is a third. In the same way, 2 divided by 6 is a third. And then the last term, let's call it the nth term, is 2 over 243. The nth term we can also write as ar to the power of n minus 1, and this equals 2 over 243. We have the value of a, we have the value of r, so from this equation we can solve for n. If I substitute a and r, 18 times a third to the power of n minus 1 equals 2 over 243. Be careful here not to multiply 18 by a third, because a third is raised to the power and the 18 must not be multiplied by the base only. What we can do, however, is we can divide left and right by 2, and then we get 1 over 243, which is 3 to the power of 5, and 18 divided by 2 is 9. Now we can divide both sides by 9. 9 is 3 squared. If I divide this side by 3 squared, then I get 3 to the power of 7 as a denominator. 1 over 3 to the power of 7 is a third to the power of 7, so that we have the same base on the left hand and the right hand side. Now, because the bases are the same, n minus 1 must equal 7, so that gives me that n is equal to 8. We must, however, determine the sum of all these terms. Right now we've discovered that this is the 8th term in this series, so we know that we must calculate the sum of 8 terms. Make sure that you substitute the values accurately. We are going to use the second alternative of this formula because r is smaller than 1. It is a third. And when you get to this step, enter all these values very carefully into your calculator, and any of these two answers will be acceptable.